Hello guys, welcome to the DSA playlist by 2am Coder. In this video, we are going to discuss about the binary search technique, and this is the very first video. So before starting the video, I just want to tell you that there are a lot of video coming in future where we will see linear search as well, and big O notation, how the time complexity and space complexity work. We will also see linked list, different collection like hash map and set. We will also see how a binary tree and binary search tree works. So just stay tuned and subscribe to my channel so that you don't miss any video. So without further ado, let's get started. Let's assume this is the array we have and this is in sorted nature. Why sorted nature array? Because we have to apply binary search in only. So why sorted array? Because we will apply binary search only in the sorted array. We cannot apply binary search in unsorted array because for that we have linear search technique, which is not that efficient because binary search takes big O of log n time complexity, which is much faster than the linear search technique, which take linear time complexity, which is big O of n. Okay, so we will see how the binary search work. So here you can see we have three target. So first we will see 7 and how we are going to search 7 in this array. So how binary search work? We will keep dividing the array until we find the target element. So this is the mantra of binary search. And how we will divide? We will divide the array in two equal parts. And for dividing the array in two equal parts, we need a mid element. Okay. So let's quickly write the pointers. So for that we need starting pointer and end pointer. Initially starting pointer will always be 0 and end pointer will always be the last index of array, which is length minus 1. Now we have starting and end point. We need midpoint to divide the array into equal part. Okay, and for that we will just divide it and divide it by 2. 0 plus 11 divided by 2, which is 5. We will keep it here. And why 5? By not 5.5? Because it's integer value. So I hope you know this. So there will be three cases where our target value lies here in the array. So based on that, we will divide the array in half portion. Okay, and we will eliminate the other half portion. So for that, we will check if the target element is equal to the mid element. So in our case, it's not equal, and whereas it is greater than the target element. That means our target lies in the left half portion. So what we will do, we will only consider the left half from the mid and we will eliminate the right half portion. So this will be eliminated. This is eliminated. Why? Because you know your target value will never lie here because it's always less than the mid element. So when you say you have eliminated, how will you eliminate? For that, what you need to do, you just need to shift your end point from here to mid minus 1. And why mid minus 1? Why not mid? Because you know it's not available in the mid position, otherwise you would have find it initially. So you will shift it to the mid minus 1. There is no point of keeping it in the mid position. For now I'll keep it here. Now you have new starting and end point. Again you will search, you will apply the binary search in this particular portion. Now this is your new array, new sorted array. Apply the binary search again here. Your starting and end point has updated. So start as a 0, end point is 4, midpoint will be 2. We will move the mid to here. Now again what you will see if the target is equal to the mid or not, or if it is lesser than or greater than the mid element. So in our case this is greater than the mid element and it is not equal to mid. So what will you know? So now you know your target element will lie in the right portion of the array. So we will eliminate this particular portion. Now you have only two elements in the array. So let's quickly create one array here. It's 7 and 9, indexes 3, indexes 4. Okay, so as you know, we have eliminated this array. So when you say eliminated, what does that mean? It means you will shift your s from here to mid plus 1. And why not mid? And why not in the mid position? Because you already know we are not going to consider m because we would have find it, so no need to consider the mid as of now. So this is your new starting and end position. Again what we will do, we will divide the array and we will find the mid element and then we will see whether we need to divide it or we found the element. So 3 plus 4 equal to 7 and divided by 2 will be 3. So this is your mid position. So now you know your mid is equal to the 7, so you found the element. So you can see how many iteration it required. You eliminated this particular portion, so this was the first iteration and this was the second iteration when your left portion was eliminated, and this was this third iteration. So you find the element in the third iteration itself. Okay, and if you would have taken the linear search approach, it will check each element and it will take a lot of time to reach to that particular index, right? So this is the best way to search any element in sorted array, because you know the other half portion will be eliminated. So you are reducing your search space by half. So that's how it is efficient. So we will see how we will execute it. So this is the starting and end position we initially we will have, and as you know we have to find the mid element. So let's find the mid element here. M equals to S plus E divided by 2. In our case, what will be the value here? 0 plus 11 equal to the 5. So this is the mid. Let's quickly paste it here. Okay, so this is the mid value in 7. So we are considering 7 as the case. Now we find the mid element and we have to find whether that particular target is equal to that, or whether it's lying in the left side, or whether it's lying in the right side. For that we just need to take those three cases. Case 1, whether your array of mid is equal to the target element. So in that case what we will see, we found the answer, found the element. Case 2, where we say our mid element is greater than the target element. So in that case what we will do, we will see. And case 3, where your mid is less than the target element. So in this case what we are going to do, we will see by executing. So here you find the mid element. You can see this is not the target element here in the mid position, but you know this is the greater than of your target element. So array of mid is greater than the target element, so this will lie in the second case. What we will do, we will eliminate this particular portion, the second half. For that what we are going to do, we will just move this from here to m-1. Okay, so what we will do, we will make e as m-1. So now our new value will be our new e value will be m-1. Now this is the new array we have. Let's make a border here. So this is our new array. Now what we are going to do, we are going to find the mid. So mid is this is the formula to find the mid, and starting remains the same and has changed, so this will update it as 4. Now 2 plus 4 is divided by 2. Oops, I forget to add divided by 2 here, so this will be divided by 2. Okay, now mid value is 2. It will be here. Again we are going to check if it is equal to that, or if it is lesser than or greater than. So if it is equal to, found the element, it's not the case. And let's see the second case. If mid is greater than the target, no, it's not greater than the target, so we will check the third case. If mid is less than the target, yes, it is less than the target. So what we are going to do, we will eliminate this first half, right? Because we don't need that, because we know our target lies in the right side because it's greater than the mid. So we will just shorten this array to this portion. And when we say we have shortened the array, what does that mean? That means we will change the s value from here to mid plus 1. When target is greater than mid, at that point of time we will make s as mid plus 1. So now we will consider only this array. So here we are not changing the array value. The array value will remain the same. We are just changing the starting and end point. As you can see, the array value will, we are not creating new object of array. Okay, that we will see in the code. Now you have new starting and end point. What we are going to do, we will find the mid element. Now your starting point has updated from 0 to 3. 3 plus 4 is 7. 7 divided by 2. Again, it's integer, so 3. So mid value is 3. Mid will come here. Now again, we will check if mid is equal to the target. Yes, it is equal to the target. So we found the element. So you can see this is how we find the element in binary search. So let's quickly do the same with second case. This is the initial position, and yeah, we will make it 0, 11, and this will be 5. Starting and end mid will be 5. So quickly we will copy paste. This will be mid value, and now this is the second case where target is 31. If it is equal to that, no, it's not equal to that. If it is greater than mid is greater than the target, no, it's not greater than the target. Is it lesser than the target? Yes, it is lesser than the target. So in that case, what we need is, we need only this portion, because we don't need this. We know the target lies in right side of the mid, so we will update the s. It says make the s as n plus 1. So now this is the new value. We are going to find the mid element again. S has changed from 0 to 6. So it's 17 divided by 2 will be 8. Now mid value is 8. Let's quickly keep it here, and we are going to, so now we will check if it is equal to the target. No, it's not equal to the target. If it is greater than the target, no, it's not greater than the target. Is it lesser than the target? Yes, it is lesser than the target. 25 is less than 31. So again, what we will do, we will make s as n plus 1. It will come here. Let's quickly move it here. Now what we are going to do, again, because we have checked these cases, now again we will find the mid element. Now your s value has updated from 6 to 9, and we know 9 plus 11 divided by 2 is 10, so we'll make it 10. Quickly we will move it here. Now again we will check if it is equal to the target. 45 is not equal to the target. If it is lesser than the target, yes it is, sorry, if it is greater than the target, yes it is greater than the target. In that case, what we will do, we will make the endpoint as m minus 1. So we'll quickly shift here, and we will remove it, and now you have new s and endpoint. We will change this to, sorry, this will remain same, this will be 9. It's 18. M value will also be 9. Now you can see all the points are at same place. Now again we will check the cases. If it is equal to the target, yes it is equal to the target. So now you found the element, so you can return the element itself, or you can return the index value. Quickly let's check the third case. Okay, so we are not going to change the mid value here, because you know that simple calculation, right? So this is the mid value here. So without doing any calculation, we will directly see how we are going to search the next element. Next is 12. So the first case is equal to the target. Yes, mid is equal to the target, so we don't need further division here, because it find the target in the first step itself. Okay, so we will directly return the other index or element itself. You can see this is much faster, right? You find the element in the first iteration itself. If you would have taken the linear search, it will check each element and then it will find it. So it's a bit of time taking. But here in binary search, it will find it in one first iteration itself in some cases. Okay, so this is the best case, and there will be some worst case as well, but that worst case is also more efficient than the linear search. So let's see how we'll do this. Let's quickly create one package. So here what we need when we find the element in binary search, we need int array, we need target element, we need starting element, and we need we need starting point, and we need end point. Okay, so as you know, initially what we need mid element, so this will be your mid element. And let's write it as start and it is end. Let's find the mid element, start plus end divided by 2. So that's how we write here, right? This is the same thing, this is the algorithm, and same thing we are going to write it in a form of code. This is the mid element. Now we will check the condition here. If array of mid, if it is equal to the target element, what we will do, either we will return the element itself or we will return the index. So I'll choose returning the index. So index is mid is index, right? Here we are dealing with index value. Start end is index value, so mid will be your index value, mid index. Else if array of mid, if it is, what is the second case, if it is greater than the target, right? So in that case what we are going to do, we are going to make end as mid minus 1, correct, and is equals to mid minus 1. And third case will be when your mid element is lesser than the target element. This is the third case. So we don't need to write else if for that, because that's the only condition left now. So how many conditions you will have? You will have only 3 conditions, right? Either it will be equal to that, or it can be less than that, or greater than that. So you don't need to write again else if for that. Your start will become mid plus 1. Yeah, start will be mid plus 1. So you will do it until when? So you will keep repeating this until you find the array. So let's assume if the item is not available in the array, so how you are going to limit the, because you will keep repeating this thing until you find the target value, how you can limit your iteration? As you can see, you are moving s or start value always to the right side, and your end will move always to the left side if you want to divide your array, right? So I'll remove this. So when your start will cross themselves, when your start and end point will cross themselves, or you can say when your start will become greater than the end point, at that point of time you need to stop your loop. Okay, so you will do it until s is less than or equal to the end point. Repeat this particular portion until you find your target value, or when it start is less than or equal to the end point. As soon as start will become greater than the end point, we will break the loop and it will be taken. When we say the loop has broken, that means the item is not available. In that case we will return -1. So it's your choice. The binary search method work is done, so we will directly call this method from here. Binary search will pass the array, we need target value, we need starting as 0 initially. Starting will be always 0 initially, and end will be your length -1. So this will be your end index. This 11th is nothing but your length -1. Okay, what it is returning, it is returning the index value, so we will say index. Okay, it can return -1 as well when the element was not present. So we will say if it is not equal to -1, that means element is available and we found the element, otherwise not found. Or we can say position. Okay, that looks good. Just run this program. So you can see 7 found in third position. 1 2 3 Okay, it's index value, right? So if you say position, for that what you can do is you can just make it +1, so it will give you the position, not from 0, from the 1, 1 2 3 and fourth position. And let's try to find 31. That was our second case. 31 found in 10th position, so this is the 10th position. And let's see, yeah, it's working. So this is the approach we are going to take when you are searching any element in a sorted array. So this is with the while loop, and there is another approach which we call it as recursive approach. So better I tell you that as well, because later you will work with recursive approach in many algorithm. So this is the easiest, so better you practice your recursive approach in this concept only. So we are going to do the same thing, but not with the while loop, because we are going to do the same with a recursive approach. So when you say you are updating the end value here, and you know your binary search is taking those particular uh, parameters, and you know what is the recursive. If you don't know, then recursion is nothing but when your method call itself. So in our case, we will call this method here, these two places. Binary search, we will pass the same array element, and target we will pass as it is. We will pass start as it is, because we are not changing start here, but we will pass end value as the updated value. Okay, and now we don't need this. Same thing we will do here when we update the start value. We will call the binary search method, and instead of passing the start, we will pass it the mid +1, and your end value will remain same, because here we are only updating the start value. Okay, so you are updating, and how it will work when you call this. Let's make it 7. When you call this method, it will take the mid value. Okay, fine. If it is not available, when this condition satisfied, what it will do, it will call the method again with updated end value. So what we are doing, we are doing same thing what we were doing in a while loop. We are calling the same method again, and we are doing the same thing again with updated start or end value. Here start value is same, because we only need to update the end value, and when it will call again, it will execute same thing again and again. And this, when this block will execute, this will update the start point as mid +1, and this will call the same method again with the updated value. Okay, so at the when you call this method again and again and again, at the end, either you will find the element, or you will not find the element. When you find the element, you will return the index. So this method will return something, right? So from here also we should say return, because this is returning the index value when it will find the element. And there will be second case as well, when your target element is not present in the array. So for that, as I said, we need to limit, right? So for that, we will just write a condition less than or equal to the end value. If it is not, then we will return -1, and we have already handled here -1 not found. So when you are calling this method, it will check if it lies in these two conditions, then it will call this particular method again and again and again with updated end and start value. If it is satisfied, it will check again. If it is not satisfied, that means we have reached the limit and that particular element is not available in that point of time. It will return -1, and in every iteration, the -1 will come here, and it will go to the stack, method stack, and previous whatever method you have called from here, or either from here or from here, it will return again -1, and at the end it will come here, and you will have the -1 value here. Okay, so this is how it works with the recursive approach. We will see how recursive method works in later video, so just stay tuned, and let's try to run this program. You can see 7 found in first position, so that's working. It's up to you. You want to follow the while loop approach or the recursive approach, but best way is to follow recursive approach, because later in many algorithm you will find the recursive approach, and that will be a very complex calculation. So that's it from this video, guys. If you liked what you saw, just hit the like button and share with your friends. I'll see you in the next video. Till then, bye bye.